right, well, we are beginning chapter 10, and chapter 10 is all about quadratic functions, their different characteristics, how to use them, how they can model things in the real world. And the second half of this chapter is all about using them to solve different types of problems. So today our focus is going to be about what makes them special, why are they interesting, and what are those key characteristics. So we're going to start with some vocabulary. So as you can see, our essential question right here at the top, what are the characteristics of quadratics and how do we use them? So a quadratic function is any function that can be written in the form f of x equals ax squared plus bx plus c. Remember that f of x is just a fancy name for what comes after that equal sign. This would be exactly the same if it said y equals something squared. The key thing here is that it has to be the highest exponent, or the degree of the polynomial has to be 2. That's what makes it a quadratic function. If the degree was 1, meaning this first term was missing, then it would actually be a linear expression or a linear function, and we would be talking about something from first semester. So that's what all this stuff on the bottom, where a, b, and c are real numbers and a is not 0. So quadratic function, any function of degree 2. So now that we have talked about what a quadratic function looks like from an equation perspective, degree 2, we're going to talk about what a quadratic function looks like graphically. And when you graph a quadratic function, the name of the shape that you see is called a parabola. So a parabola is a U-shaped looking graph. It can open up, it can open down. In future classes, you'll actually talk about horizontal parabolas that open sideways to the left or to the right. But for purposes of Algebra 1, we're talking about parabolas that open either facing up or facing down. So that name, that shape, in blue over here on your graph to the right is called a parabola. Parabolas are symmetric, meaning there is a place where you could really, if you had a piece of paper in front of you, fold the piece of paper along a special line and everything would line up perfectly. And that line is called the axis of symmetry. So the axis of symmetry, which you're going to see on notes and worksheets and things abbreviated as AOS. And you're going to see over the next few lessons how the axis of symmetry and that idea of how parabolas are symmetric is actually going to mean that you get to do less work, which is always a good thing. The next key feature of a quadratic function is the vertex. And the vertex is this point down here, is either the highest or the lowest point on a parabola. I want you to notice that the axis of symmetry physically goes right through that point. Like my dotted line is going down and crashing into that point, the vertex. We will often talk about whether the vertex is a maximum or minimum point. So on this graph over here on the right, it is a minimum point because the U-shaped graph actually never goes below that point. That's the lowest it ever goes, which means that point is the minimum. If we had a parabola like this one that we just kind of sketched right here that opened downward, this point would actually be the maximum because it doesn't go any higher than that point. Something important that I want you guys to notice is that sometimes you're going to be asked for the maximum or minimum value, and that is only talking about the y value of the vertex. Remember that a vertex is a point, which means it's an ordered pair. The x part of your vertex is the axis of symmetry. The y part of your vertex is the maximum or minimum value of the function. The last thing we're going to talk about, which actually ties back to looking at an equation, is if the a value, meaning the number in front of your x squared term, the leading coefficient, if that is a positive number, then your parabola is going to open up. So if a is positive, you're going to have a parabola that opens up. If a is negative, then you're going to have a parabola that opens down. And that's just going to help you identify things about the maximum and the minimum without even having to graph. So now that we have identified these key characteristics, we're going to talk about how to identify them. Okay, let's look through these examples that are on the bottom of your page of notes. And let's just work it on one piece at a time. So the very first thing I'm going to do, and if you happen to have this paper printed in front of you, then I'm going to have you do this as well. What I'm going to have you do is right now I want you to grab a color, maybe a highlighter, maybe a pencil, and just draw a dotted line where the axis of symmetry would be. If you don't have a paper, then just use your finger and kind of draw over and see if you understand where that line, which is the axis of symmetry, would be on your graph. So the axis of symmetry, and a big thing about it, is that the axis of symmetry is a line, and it is a line that goes through the vertex. It's a vertical line, which means anytime we write the axis of symmetry, we are going to write it as the equation of a line. So every single axis of symmetry is going to say x equals, and it's going to say x equals whatever the number, the x value of the vertex is. So go ahead on each of those problems where it says axis of symmetry, write x equals. X equals. If you just write a number, then you're not actually telling me what the axis of symmetry is because it's a line, it's an axis. It has to be written as x equals. So looking at this first graph, the x value, what x is along this dotted purple line, here is -1. Looking at number 2, the x value along this dotted purple line is 0.5. And looking at number 3, the x value along this dotted line here is -4. So stop, make sure you understand the x value of the vertex is the line that gives you your axis of symmetry. Okay, we're going to move on to the vertex, but before we do that, we actually just identified the first half of every single vertex point that we have. The first half of our vertex is the x value that is the axis of symmetry. So I know that the vertex is going to be an ordered pair, and I actually know what the x value is. We just said that the axis of symmetry is x equals -1. That means on number 1, the vertex, the x value is going to be -1. On number 2, the vertex, the x value is going to be 0.5. Number 3, the vertex, the x value is going to be -4. Now, I'm going to use blue to find the y value of our vertex. Well, when we have the graph to find the y value, we just need to go to the vertex and actually find that indicated y value of the ordered pair. So for number 1, the vertex is at the point -1, -4. And on number 2, the vertex is at the point 0.5. We already had that part. And then our y value, which is 4.25. Number 3, the vertex is at the point -4, -1. So -1 is the y value that I need to add. So notice the axis of symmetry is a line, and it's x equals. The vertex is an ordered pair, an xy point. Now we're going to look at each of those points and we're going to identify if it's the highest or lowest point on the graph. So if you look at number 1, I'm going to darken this vertex here. That vertex is the lowest point that parabola, the red parabola, ever goes, which makes it a minimum. If you look at number 2, this vertex is the highest point that parabola ever goes. Everything to the left or to the right of that point is going downward. That means that point is the maximum. And if you look at number 3, just like number 2, everything to the left and to the right of that point is going down. It's lower, which means that point is the maximum. So what we just did is identify if each vertex is a maximum or a minimum. Now we need to identify the value of the maximum or the minimum, meaning looking at your y's, what is the highest or lowest that it ever goes? So I'm actually going to use that blue color again because that number is going to be the same number here. So on number 1, the lowest that this graph ever goes is -4, which actually means that our range, which has to do with y, our range is going to go from -4 up to infinity. So remember on the left, we're putting the lowest possible value, and I have square brackets there because -4 is on the graph. And those arrows on the ends show that this parabola is going up forever, which means that I'm going from -4 up to infinity. If you look at number 2, the maximum value, that y value, is 4.25. and that is the highest that the graph ever goes, which means in interval notation, that is actually going to be on the right-hand side. And I'm going to have square brackets again because it does actually go through 4.25. Now, the lowest this graph ever goes, if you look at it, it's going down on both ends, and it's going down forever, which means it's going down to negative infinity. And I'm going to have parentheses because the thing about infinity is that we don't ever actually get there. And then number 3, the y value of that vertex is -1. That is the maximum value, which means our range is going from negative infinity up to -1, square bracket with -1. The very last thing we're going to talk about is the domain. I saved the easiest for last. Don't worry. I know this has been a lot in a short little lesson. The domain is what's happening with the x's. Well, let's look at what's happening with the x's. On the left of my graph, going left, there's an arrow, which means this graph goes left forever and ever and ever, which means the domain is going to negative infinity on the low end. Let's see what's happening on the high end. This is all continuous, it keeps going, and then now that I'm on the right end, it's also going right forever, meaning that the domain is actually all real numbers, negative infinity to positive infinity. Let's look at number 2. On the left, forever going left. Again, don't think about this as up and down when we're talking about domain. Think of it as left and right. It is going forever left, and it's continuing and then going forever right, which means the domain is negative infinity to positive infinity. If I can get this to right. And no, that's not a coincidence that it happened the same way on the first 2. The domain of every quadratic function that is continuous is going to be negative infinity to infinity. That's going to change a little bit when we start talking about word problems. If we start talking about time, it doesn't make sense to talk about negative time. So that might be modified. But here we're looking at graphs of continuous functions, meaning they're going on and on forever. So the domain is going to be all real numbers, or negative infinity to infinity. So a couple key things I want to remind you, things that always get forgotten. The first is that these are all quadratic functions, degree 2. The second is that point that is the highest or lowest is called the vertex. And the vertex has important things like that the x value of the vertex is the axis of symmetry, and that has to be written as a line. X equals that x value of the vertex. And that the y value of the vertex is the maximum or minimum value of the function that we're talking about. And I think that's it. So I hope you guys enjoyed this lesson. Write down questions, email me them, or put them on the Google Classroom, and we can talk about them more in our office hours this week. Thanks, guys.